So hello everyone, this is Vedant Patil and here we are today in order to give you a presentation for our IVP project, and our IVP project is image foreground extraction and background replacement. And this project is presented to you by myself Vedant Patil. My teammates are Deepak Gohil, Dev Parmar, Nitin Gautam and Abhijit Singh. So let's get started. First I will be telling you why we are doing this project. We are doing this project because in our world we have a variety of images, and many a times what we the photo which we click and the photo which we want to see are different, and in order to fill that gap we are doing this project. And how our project will be able to fill this gap is by separating the foreground image from the background image. Now when we separate the foreground image from the background image, we have an option in the end to add a different background to our foreground image, so that our image will look much more clear, cool, admirable, and it will be found more attractive to the audience. Now let's talk about the workflow. So in the workflow, we have majorly three steps: image thresholding, morphological operations, and overlay on new background image. So the image thresholding process is responsible for creating a mask, and there are different kinds of image thresholding processes, and we can select select one of these depending upon the nature of our image and the characteristics of our image. And then after we get our mask. Now no mask can be perfect, and in order to make that mask much more efficient for our process, we perform morphological operations. These morphological operations, they kind of fill holes, and they are responsible for noise reduction and feature extraction. And in the end, as I told you, we will be replacing the background by a new background, because now we have removed the background from our image. Now we will be replacing it with new background, and hence in the end we will be having an image which will be much more better than the image which we got into our system as an input. So now my teammates will continue further.
Hello everyone, I am Dev here. Let's understand what is image thresholding. Here we are going to use global thresholding, in which it involves selecting a single threshold value for the entire image. It is a straightforward method, and what it does is, uh, in simple binary thresholding, the pixels above the threshold are set to 255 value, that is white, and those below are set to 0, that is black. And in inverted, the pixels above the threshold value are set to 0, and those below are set to white, that is 255. Here we can see the example. This one is inverted, and this one is binary. Now let's see what is Otsu's method. Otsu's method aims to automatically determine the threshold value for image segmentation by maximizing the interclass variance. It By maximizing the variance, it can separate the foreground and the background. Uh, it iterates for each intensity level. It calculates the cumulative sum and cumulating sum of squared intensity using the normalized histogram. Then the optimal threshold is the one that maximizes the sigma square, and the computed optimal threshold is used for image segmentation. The advantages of Otsu's thresholding are that it automatically adapts to image content, and it is effective in handling varying illumination.
Hello everyone, myself Deepak Goel, and I am going to cover this topic of morphological operations. So, morphological operations on an image involves modifying the geometric structure of an image. So, these morphological operations are used in various purposes like noise removal, edge detection, and shape analysis. There are basically two operations in morphological operation. That is one dilation and second is erosion. So, let's talk about dilation first. Imagine we have an image of various shapes. So dilation expands the shape by adding the pixels to its boundary. It helps the object to make it more visible and fill the gaps in the contours. On the other hand, the erosion shrinks the shape by removing the pixels of their boundaries. It helpful in some segmenting the image and extracting the object from the image. Now let's discuss more complicated morphological operation, they are made using the combinations of dilation and erosion. These morphological operations are morphological opening operation and morphological closing operation. So the morphological closing operation is a sequence of image erosion followed by image dilations. So basically, we first do some combination of erosions which fine tunes the object and remove the noise in them, and then we do the morphological dilations which expands the object and reduces the noise and highlights the overall structure. So here in the image we can see we have applied the morphological opening operations. Now let's talk about morphological closing operations. So in these techniques, it involves like doing first dilation of the image and followed by erosions. So this will fill out these gaps between the images and improve the connectivity and maintain the counter of the shapes. So that's it from my side.
Hello, myself Abhijit. I am going to explain how to overlay a new background on an image using image processing. This process is also known as alpha composting. To overlay a new background on image, we have to first load the image and load the foreground image and the background image. Then we have to create a mask, convert the foreground image to grayscale and create a binary mask. And after that, we have to invert the mask. After invert the mask, we have to combine the images using bitwise operations to combine the foreground and background image based on the mask. The overlays foreground on the background. In alpha composting, the binary mask is denoted as mij, where and the inverted binary mask is denoted as dash mij. These are the foreground operations, and these are the background operations. Here we can see that the original image, we have extracted the foreground image, and after that we have replace it with the new background image.
Hello, I am Nitin and I am going to explain the code. So this function performs the binary threshold and this function performs binary erosion and this function performs binary dilation and this function is for invert the mask and this function replace the background. So now let's run the code. This is our original image and now this image, this is a binary image and now we use a kernel of 5, 5 and this is the eroded image. Now this is the closing image and this code and this is a foreground image and this is a final image of the presentation. The success of this methodology lies in adaptability to diverse the scenario, making it applicable in image editing, object recognition, and scene composition. The stepwise visualization presented in the project not only provide the clarity on each processing stage but also underscore the significance of a systematic approach in achieving a high quality result. Thank you.